Hello guys and welcome back to the channel. So in this video we are going to talk about tracking algorithms in OpenCV. So we will understand how tracking works and how we can track almost any objects in the frame. For this video we are only going to track persons in the video file, but you can apply these tracking algorithms for any of the objects you want in your video file or a live video feed from the USB webcam. So before starting, let's just understand how tracking algorithm works. So one of the algorithm which we are going to use is the Centroid tracking algorithm. So how this algorithm and almost all algorithm works is that they keep on tracking the coordinates of the objects in the frame. In our case, we are tracking the person, and thus what we will do is we will keep on feeding the coordinates of the person to the tracker. What tracker will do is it will save the coordinates and then it will compare and calculate the distance between the current coordinates and the previous coordinates. And if it is below some threshold value, it will keep tracking the object, or else it will not simply track and will consider it to be a new object. So, for example, let's understand by looking at few of the examples. So, let's say let's say this is our frame, and inside this frame we have an object somewhere here, and we also have another object somewhere here. So what our tracker will do, first for the first frame it will assign these two objects an ID. So for example the object ID of this particular tracker is, let's say, 0. Let me just make it a bit small. Object ID 0 and write it here, object ID is 1. Now this is for the first frame. Now what will happen in the second frame is that this particular object will basically move from this position to, let's say this particular position, or it can move to this position, or it can move to this position, or let's say this position. But it is not possible, it is not practically possible to for this object to move from this particular position to this position in just one frame. So it can only move to these directions and these positions. So what our tracker will does is it will compare the coordinates, these coordinates with this coordinate, and if it is below some threshold value, it will keep assigning the same object ID. So in this case, this will again be 0. And let's say in the third frame, this particular object ID move to, let's say, this particular place. So it is again below some threshold value, so the object ID will again be 0. Now let's say for some reason this particular object is not present in the frame and it has gone out of the frame. So it will keep on waiting here for some particular time, for some particular frame, which we will define in the tracker. So after that frame, if the if within that particular number of frames, if the object returns, it will assign the same object ID. Otherwise, it will assign a new object ID. So in that case, the object ID will be 2. Reason being, because we already have object ID 1 here. So this cycle keeps on happening and happening and happening, this and in this way the tracker keeps on tracking a particular object in the frame. Now this is all about how tracking algorithm works. I already have a code for the algorithm. I'll put the link in the description so that you can also use it. It is this centroid tracking.py. So we are going to use this particular um, code in our project, and we will detect and track the persons in the video file. So this was about the tracking. Another thing which we need to understand is the non-MEK suppression. So the model which we are using to detect persons works perfectly fine for almost 95% of the cases, but it also sometimes gives false detection. And by false detection, what I mean is that it also detects wrong object. So let's say you are detecting a person in the image, and in that image file there is only one person. So ideally there should be only one bounding box. But because of the false detection, there can be two or many bounding box, which actually doesn't look good and is known as noise. For example, if you look at this particular image, you can see that the face is getting detected, but there are many other bounding boxes as well, which are basically the noise. So what non-MEK suppression does is So when you apply this algorithm, it checks the overlapping boundary boxes and merge all of them in such a way that the output image contains no noise and is 100% accurate. So as you can see in this image, before applying the non-max suppression, there are like I would say 3 to 4 bounding boxes for one particular face. But after applying the non-max suppression, all those are gone and we have the final product, final bounding box for the face. So this is what non-max suppression does is, and it's a good idea to apply this in our code because we will also face this issue of getting false detection in our test video file. So this was also about the non-max suppression. Now let's get started with our code. So for the coding part, I'm going to use the same code which we discussed in our previous video while we were detecting the persons in the test video file. So let me just create a new file and I will name this file as person tracking. Now I will simply copy all the code from my person detection video file and I will paste it here. Now we are going to modify this particular code to enable tracking in it. So first of all, we are going to include the tracker. So I will import. So I will use from Centroid tracker import Centroid tracker. Now somewhere here I will initialize my tracker. So tracker equals to Centroid tracker. Now it accepts two parameters. So first parameter is max disappeared. So as we discussed in the first part of this video, max disappeared is the number of frames we want our tracker to keep waiting for the objects. So if an object moves out of the frame, our tracker will keeps waiting for this that particular frames which we are going to define here, so that if the object comes back, it will assign them the same object ID. So we will take it as 80. This totally depends upon application to application. So if you have a like you must have any other type of application, so you can vary this particular value to as per your needs. So now here we are going to take max distance, which we are also going to keep it as 90. Now this is done. So in our so here we are reading the test video file, and this is for the displaying the frames per count. We are going to So inside this for loop, we are basically detecting all the persons. So we are going to edit this part of the code, and somewhere we will not include this thing, but what we will do is we will take a list where we will save all the coordinates. So I will take a list here, rects, and inside this rects, I will append all the rectangles, basically all the coordinates of the persons which our code is detecting. So here I will mention person bounding box. So in this list, I have all the coordinates of the person's bounding box. Now, what I need to do is this person's bounding box may contain some of the noises as we discussed. So I need to first apply the non-max suppression algorithm here, and after that, we will have the correct detections. So it will remove the noises from it. So I will take bounding boxes and I will convert all these bounding boxes into integer. Now here we need to apply the non-max suppression, but for this, let me just copy the code. I'll put the link to all the files in the description so you can use it in your code as well. So I will, after my tracker, I will create another function. This is the non-max suppression. Now I will simply pass all my bounding boxes to the non-max suppression. So for this, rex equals to non-max suppression. I will pass all my bounding boxes and I'll give the threshold value as 0.3. So after this, this particular variable which we have, this contains the correct boundary boxes, and it does not have the noises in it.